Hello everybody, welcome to lecture 6. Evapotranspiration is the lecture 6, which is a very important topic of irrigation subject, not only for micro irrigation, but when we deal with irrigation engineering or even drainage engineering. Evapotranspiration plays an important role, and let us try to learn evapotranspiration and then what are the different processes which are involved in evapotranspiration. So, here our basic topics which we will discuss in evapotranspiration, what are the different terminologies which are used, and then in this lecture we will also deal with factors which influence evapotranspiration processes, and then there are various ways to estimate evapotranspiration. So, one of the approach is water balance approach. So, we will deal all these concepts in this particular lecture. Now, when we come to hydrologic cycle, so if we look at the hydrologic cycle, you can see here the precipitation is the input part of the hydrologic cycle, and then when precipitation in the form of rainfall or snow or any other form where it takes place, it falls on the ground or on vegetation, and then part of this water it is intercepted by the vegetation plant foliage, and then it comes on the ground surface. So, when it is falling on the ground surface, there is one particular process which is a very important process known as infiltration. So, infiltration takes place, and when the infiltration goes for a longer period, then this water it goes to percolation, and then that causes a rise of water table. Now, when the precipitation or rainfall is more than the rate of infiltration, some part of the rain it will generate as surface runoff, and when it goes there it appears as a spring or it appears as a base flow on the ground above the ground surface. So, surface runoff appearing as spring, appearing as various other processes, and then it becomes a water body. Then another part of hydrologic cycle is evaporation. So, part of the water which is available above the ground surface, on the land surface or over the water body, it evaporates, it condenses, it forms a water vapor, it forms a cloud, then condensation takes place, again it is the process, and then from the plant body, from the leaf foliage, what we see, transpiration takes place. So, evapotranspiration, when we see, it is one of the major components of hydrologic cycle that affect crop water demand, and quantification of evapotranspiration is important from irrigation planning point of view. Irrigation this is your design point of view. Now, evapotranspiration, here there are two terms involved, one is evaporation, another one is transpiration. What is evaporation? It is the process by which water is lost to atmosphere in the form of vapor from natural surface such as free water, bare land or from live or dead vegetation. Transpiration is another component of evapotranspiration, and it is the process by which water is lost in the form of vapor through plant leaves. So, when we say evapotranspiration, it is a combined loss of water from soil or from the plant surface, and also transpiration, that is a plant transpiration surface to atmosphere through vaporization of liquid water. So, these two terminologies, this the effect in the evapotranspiration, means they are combined terms are evapotranspiration. Now, the left side of the left side of the figure, if we see, the transpiration is taking place from vegetation, from the leaves of the plant. Evaporation it is taking place from the soil, from the bare soil, and temperature and humidity is influencing the water. So, when the precipitation it occurs, it causes the increase in the soil moisture content, that water which is stored in the soil pores, that is available for the plant to transpire, evapotranspiration takes place. So, here in this particular left side of the figure, you will see the evapotranspiration, both the components are shown. There are vegetation. In the vegetation, if you see the leaves which are contributing to transpiration process, soil which is contributing to evaporation. So, bare land, water surface, these are the responsible for evaporation process. Water which is stored in the soil is available soil water. So, evaporation takes place from the water available in the soil, that is available soil water, and then transpiration takes place through the process when the water is taken by the root uptake. Now, when we see any plant which is growing from sowing to the harvesting stage, the leaf area index, means ground cover is increasing by the plant foliage. Accordingly, the transpiration process or component of the transpiration is increasing, and as the ground cover or leaf area index of the ground is increasing, the soil evaporation, contribution of evaporation from the soil surface is decreasing, and this is the trend which we see, but it is a combined effect of this evaporation and transpiration is crop evapotranspiration. So, when crop is small, or we can say its height is less, the water is predominantly lost by soil evaporation. That is what it is explained in this particular right side of the diagram. But once the crop is well developed, means it is completely covering the soil, transpiration becomes the main process. So, evapotranspiration rate is normally expressed in millimeter per unit time. We express in millimeter per day, or when we make it for on a week basis. So, this can be a weekly evapotranspiration how much. So, we use this value in millimeter per day, or in a week time how much evapotranspiration it is computed, that is used for the design of irrigation system. Now, there are various terminologies which we use in evapotranspiration. So, one terminology is potential evapotranspiration. As the term it says that potential evapotranspiration means the evapotranspiration that occurs when ground is completely covered by actively growing vegetation where there is no shortage of soil moisture. PET concept means potential evapotranspiration concept was introduced by Thornthwaite as early as in 1948, and he established expression where potential evapotranspiration is directly related with the temperature of the particular place. Conjunctive use is another terminology which is used in evapotranspiration. So, Cu we call as a conjunctive use in a short form, and it is the loss due to evapotranspiration water that is used for its metabolic activities. The Cu value it exceeds by evapotranspiration by the amount of water used for digestion, photosynthesis, transport of minerals and photosynthesis, structural support of the plant and overall total growth of the plant. This difference between ET and Cu is just a difference of 1%. So, ET and Cu they are used means synonymously, or one can use Cu or ET, both the terms are used simultaneously. And there is another term which is used as a reference evapotranspiration, and symbol wise it is a standard symbol, we call it, we put it as a ET naught or ET 0. So, it is the potential evapotranspiration for a specific crop. Usually it is grass or alfalfa and a set of surrounding advective conditions. A reference crop evapotranspiration from an extensive surface of green grass of uniform height of 12 centimeter. It is actively growing, it is completely shedding the ground with albedo of 0.23 and having ample water supply is called a reference crop evapotranspiration, and it is the modified term because there were some other investigators, they also gave that is a Wright, Durenbosch and Pruitt. Allen has brought this terminology in 1998, where he standardized the crop height as 12 centimeter. Other investigator researcher they have given different values of crop height, but in all these cases they are it has been advocated there is a it is fully covering the ground, that is one case. Second one, there is no limitation of soil moisture content. So, this reference evapotranspiration it provides evaporative demand of atmosphere independent of type of crop, growth stage and management practices which is being followed. Now, the other part which are used in evapotranspiration means other terminologies which are used here, that is a crop evapotranspiration, we call it a actual crop evapotranspiration, means it is the evaporation of the crop under standard conditions. Standard conditions here it means what is the moisture content available in the soil, how is the ground cover it is there, and then what are the soil as well as management conditions which are there. So, standard condition means the crop is disease free, means it is fully active and then it is a well fertilized. This is the important part, that it is a well disease free and well fertilized. So, that the rate of withdrawal of water from soil moisture it is adequately it is being taken out and for meeting the evapotranspiration requirement, optimal soil moisture content, and then it is producing its growth, biometric growth and all that, and then optimum production. So, from foliage point of view, production can be, suppose it is a leafy vegetable. So, optimum production means it is giving optimum yield or optimum number of leaves. From the grain point of view, when it is having the optimum production, that could be the another way of expressing optimum production. Now, adjusted crop evapotranspiration, crop evapotranspiration for the different management, environmental condition, pest disease, low fertile soil, soil moisture stress, etc. So, value of ETC needs to be adjusted as per the conditions exist in the field. Now, this particular right side diagram which you see here, the climate means it basically it is influencing. So, atmosphere practically it provides energy for withdrawing the water. So, atmosphere when we talk, it involves climate, means what are the the radiation characteristics, how much is the long wave radiation, what is the intensity of radiation, and this radiation it causes increase or decrease in the temperature, wind speed, direction of the wind, humidity, that influence, and then grass reference crop. So, crop where it is grown, it is a well watered crop, and then what is this particular grass? It is a alfalfa or a green grass. So, whatever amount of water which is used for meeting the evapotranspiration is called a reference evapotranspiration, which you see, which is given by E t naught or E t 0. Now, this reference evapotranspiration, when we are multiplying with the crop coefficient or Kc factor, which is a crop coefficient factor or Kc factor with E t naught, then it comes to E t c, that is actual crop evapotranspiration or E t c. So, this is used. Now, what are the different factors which influence evapotranspiration? In this particular slide, these factors are explained. So, energy for evaporization, that is a latent heat, which is influenced by solar radiation. What is the solar radiation? It is available at what intensity solar radiation it is falling, that is a important part, and then what is the temperature. More will be the solar radiation, higher will this is directly responsible for higher temperature, and then there will be high evapotranspiration. Then vapor transport from evaporative surface. What is the wind speed and from which wind direction wind is blowing. So, and then what is the humidity of atmospheric humidity in the surrounding where the crop is being grown. So, transport of the water vapor from one place to other place will take place depending on the wind speed and direction of the wind, and that is also influencing the evapotranspiration magnitude of the evapotranspiration value. Vegetative surface, what is the type of the crop which is being grown, what is the rooting system, and how much is the soil moisture content and how it is covering. So, this also influence, and then the intensity of solar radiation which is falling on vegetative surface, its albedo as well as emissivity. This also causes the means your the value of evapotranspiration. So, just now when I was telling you about vegetation, it influenced the evapotranspiration. So, what is the type of crop? What is the variety of crop? Any crop, it is passing through different development stages. So, one is your initial stage, another one is crop development stage, third one is crop maturity stage or crop late season stage. So, these 4 stages that influence the value of crop evapotranspiration. So, here when we talk of crop type, so it will be crop type, what is the architecture of the crop, what is the height of crop, and how does it influence the aerodynamic resistance of the canopy and to latent or sensible heat flux. A taller crop with more dense crop, it has got higher water use rate for similar surface resistance. So, means higher height crops has got more crop water intake. Leaf area index, the amount of plant, when we call up about the leaf area index. So, amount of plant foliage exposed to direct solar irradiance and amount of shaded plant foliage exposed to transmitted and reflected diffuse solar radiation. So, means more the leaf area index, more will be the evapotranspiration. So, LAI, which is the leaf area index 3 to 4, sufficient to maximize transpiration and fully shading the ground. Crop roughness, the type of vegetation, cover, its roughness, rooting characteristic, this also influence the evapotranspiration process. The particular type of crop, what type of photosynthesis, pathways in plant species that affect the evapotranspiration. So, these are the some of the crop based. Now, we can see here the how the evapotranspiration it takes place. So, water available in the soil pores, it is being extracted by the root system, it goes to the stem, and from stem it comes to the plant canopy, and then transpiration takes place. And then the what are the type of management practices, whether the there is a lot of grass is also along with the main crop. So, that will be also affecting the soil, and then what is the soil moisture available. So, if the different types of practices which is being maintained. So, evapotranspiration of the crop depending on the soil moisture condition, depending on the particular pest or disease attacked in the plant, that needs to be adjusted. So, practically if there is a without crop and then it is taken, or if it is with the fully covering vegetation. So, if that is your ET naught. Now, ET naught multiplied by Kc will give evapotranspiration requirement of the crop, and when it is having limited soil moisture content or due to some or other problem, insect or pest disease, then ETC is going to be affected, and that value of ETC is to be adjusted. Now, evapotranspiration is a very important process, and from irrigation point of view. So, it needs to be determined, and this needs to be determined, or then this can be measured directly or it can be estimated. So, if it is to be determined directly, there are methods. So, one is by using a lysimetric method or lysimeter. The another one is by using field experiment, by using soil moisture depletion studies, or by using water balance approach. Indirect way of measurement or estimation, it can be solely temperature based, it can be using the energy balance or radiation based, it can be by using the temperature as well as other climatic parameters. So, combined approach, it can be estimated by using pan evaporimeter, that can be used. The pan evaporimeter values can also be used to determine the evapotranspiration requirement of the crop. Direct measurements methods are time consuming. These are expensive, but this gives relatively precise estimate and that is normally advocated provided one has adequate facilities to determine the direct evapotranspiration measurement. Now, this particular slide you can see here a concept of conservation of mass principle has been used to determine evapotranspiration of the crop. So, practically before I come to this particular slide, let me just show you the next slide and then I will come back to this slide. So, here the principle of the conservation of mass, which we are putting that inflow, outflow and change in the the inflow minus outflow is change in the soil water storage or soil moisture content. So, inflow minus outflow is the concept which has been used in conservation of mass principle. So, what are the inflow component? Inflow component is your irrigation, P is precipitation, precipitation can be rainfall. When we are considering surface inflow due to surface inflow of water, that is surface means water is entering into the control volume. There is a lateral inflow means below the soil there is a inflow which is taking place in the lateral direction. There is a contribution of groundwater, that is a capillary rise because of the high water table. Outflow component is the runoff component. Lateral outflow means water is going out of the control volume. L is the water which is used for leaching purpose, for leaching of salts. dP is the deep percolation means water which is going because of the when the water is continuing giving as irrigation. So, some part of the water it goes beyond the root zone depth, that is a deep percolation, and there is another component which is being withdrawn, which we are talking about evapotranspiration. So, inflow minus outflow is change in the soil moisture content, which is given by change means your final soil moisture content. Theta f refers to the final moisture content and theta I refers to the initial moisture content. D or Z is depth of root zone. Now, coming back to the previous slide, which is shown here, that this is a means a system which we are taking. Now, this system is basically a soil system in which we are considering a control volume. Control volume means it is the where we are considering our study area, and in this study area your boundary is defined. Now, in this boundary we are taking different in the direction arrows are practically showing what is the input component, what is the output component. So, inflow you can see here I, that is irrigation, then P is another input component, Li is another component. So, P is precipitation, I is irrigation, Li is the lateral inflow into the control volume. So, water which is coming, this is your subsurface flow, means soil moisture is transporting from the adjoining area to the study region, and then the groundwater because of the high water table. So, there is a capillary movement or water table is contributing in the soil build up of the soil moisture content. Now, outflow component is then another component is inflow is SFI. SFI is the surface flow into the control volume. So, there is some kind of a runoff which is coming from the adjacent land into the control volume in your study region. Now, the outflow component when we are looking, so outflow component Li as we were talking. So, this is your the lateral outflow. There is another outflow component is the deep percolation, water which is being coming from the inflow and that is causing. So, it is going beyond the root zone depth or which is used for leaching of the salt. So, that and then deep percolation, LO, runoff is the another, that is runoff which is water going out of the control volume. Now, when we balance these components and these components are, so after balancing we get evapotranspiration, and this particular system it is considered in the effective root zone depth, effective root zone depth. So, your control surface or control volume is considered in the effective root zone depth. So, when we are making valence, means if we are able to maintain, means measure all these components, then we can get the valence in terms of evapotranspiration, which is I plus P plus SFI plus Li plus GW. This is your inflow component, and RO, LO minus L minus dP, and then depth of root zone theta f minus theta I. This is your final moisture content, initial moisture content. So, all these components minus, when we are telling, when we are subtracting, we are getting the value. This value is basically amount of water which is gained or it is loss from this. If it is a loss, when we say, means this water the loss is due to evapotranspiration of the crop. So, on this concept a lysimeter is used, where various components which are inflow and outflow, these can be measured. So, lysimeter is a device which is installed in a cropped field, for which we were interested to determine evapotranspiration requirement of the crop. So, there will be two lysimeters, one lysimeter where you are maintaining exactly the ideal condition, there is no shortage of water, you are maintaining you are growing alfalfa or green grass, then a actual crop which is being grown in the field, this we are growing. So, you are measuring water loss, loss means the water which is used by the plant for meeting evapotranspiration, or gain when it is coming means something which is has been aided by precipitation, it has come from the adjoining area. So, soil and crop conditions in the lysimeter are kept same as surrounding field condition. This measurement involve, it could be weighing or non-weighing type of lysimeter. We are putting a scale or floating the lysimeter in water by water or suitable heavy liquid in which the lysimeter can float, and any change in that liquid is computed against water loss or water gain. That will depend, initially first day when you are adding, that will be gain, but at the end of 24 hours you find there is a loss. Those loss components are found out. So, if the crop is of shorter height, means for short duration, then the lysimeter is of smaller size, it is used, and its a volume will be less, that is a 2 cubic meter. And then if it is a tall crop like sugarcane or any other crop which are tall, then the lysimeter could be of a larger size, it could be means 3 to 4 cubic meter, and the depth can be also increased. Now, a typical lysimeter concept, it is being shown here. There is a lysimeter which has been installed in the field, the crop is grown, the adjacent area there are in same crop it is being grown, which is, and then the irrigation or rainfall it is occurring, and then it is building soil moisture content. When the soil moisture content goes more than the saturation, then it will cause depercolation, it will go as a drainage. It may also, when the rainfall is very high, then it will form runoff, and then part of the water which is going as evapotranspiration Now, these components can be measured by using non-weighing type of lysimeter or weighing type lysimeter. In a non-weighing type of lysimeter, we are measuring different components of soil moisture content by using the several devices, and those change in the soil moisture values are used as a evapotranspiration value. Means the loss in the soil moisture content is measured. So, this is what you are seeing. This can be there is a metal or plastic membrane which is kept driven into the soil, and then a permanent device or access tube or neutron probe or any soil moisture measuring gadgets are installed in the lysimeter, where the change in the soil moisture content is measured. When we are talking about weighing type of lysimeter, this particular device is kept over a load cell. Now, load cell displacement in the load cell is measured by using the scale R in terms of weight. That those load cells are measured as we are measuring the in the strain gauges, what is the displacement in a given. So, these things are measured, and then the amount of water which is transpired are in different components, which I explained you in the previous slide. Those are monitored, and then it is the evapotranspiration is measured by using. So, water is applied in a given quantity, means amount of water is measured quantity of water is applied, which is we call it as a irrigation, and it is in the same amount as in the surrounding area. Overflow and depercolation, if it occurs, those are also measured, means all the components, rather I will say, these are measured. So, water received through irrigation, precipitation, excluding overflow, that is a runoff we can say, the depercolation, the balanced soil moisture content. So, water means the water used by the crop in the process of evapotranspiration is balanced or measured. So, this just now I have shown you that the two types of lysimeter, and then of course, lysimeter is it is a device which is measuring the evapotranspiration, giving precise estimate, but there are certain limitation here also, that reproduction of actual field condition it becomes difficult, and one is the getting the ideal water table condition which exists in the lysimeter if it is closed from the bottom. So, as well as certain field conditions, means natural density of the soil which is existing in the field, as well as soil maintaining soil texture, it becomes a difficult task, but over time when we are conducting experiment for a long time, it maintains same kind of condition as outside. So, in this particular lecture, we discussed evapotranspiration, evaporation, what are the different climatic as well as vegetative factors which influence the evapotranspiration process. We also explained about how to determine evapotranspiration by using the lysimeter. There are other methods of estimating evapotranspiration as well as determining measuring soil moisture content, and then depletion of the soil moisture content, that will be discussed in the forthcoming lecture. So, this we will be discussing. You may refer books which are here given here by Allen et al., which is FAO 56 is a very important manual of this your manual, which is a from the means your the Italy Rome, the head office available. So, this is available in the net. The book by Professor A. M. Michael, that Irrigation Theory and Practice, as well as James L. G. Larry James book. It is also a very useful book, you can refer, and there are quite a good amount of literature available, and so you may refer. So, this way I am closing here lecture 6, and I understand you have understood this particular lecture, and thank you very much and good day.